Losing your eyesight is easily preventable. You just need to be cool about the whole situation and wear your safety goggles. Don't think you're too cool, otherwise you'll end up like Carol. You can lose your eyesight to acid burns. An acid is any compound that can release hydrogen ions, or in other words, a proton. A base, on the other hand, receives that proton, or it takes on hydrogen ions. So by definition, water is amphoteric, which means it can act as both an acid and a base. The water molecule that is on the left is acting as an acid. It's giving up one of its protons, or a hydrogen ion, to its neighbor. The water molecule that's on the right is acting as a base. It's taking on a proton, or it's receiving a hydrogen ion. Water is constantly self-ionizing, so it forms equal concentrations of hydronium and hydroxide ions. This makes water neutral with a pH of 7. pH comes from Latin potentia hydronium, which literally translates to the power of hydrogen. It is the measure of the concentration of hydronium, which I have there boxed in red. The pH scale is logarithmic, which means every step down represents a 10-fold increase in the concentration of hydronium. For example, something with a pH of 6 is 10 times more powerful than something with a pH of 7. Something with a pH of 5 is 100 times more powerful or more acidic than something with a pH of 7. And this is also relative too. So let's think about something with a pH of 3 versus a pH of 6. How many more times acidic is something with a pH of 3 versus 6? I'll give you a second to figure it out. The answer is 1,000. Something that has a pH of 3 is 1,000 times more acidic than a pH of 6 because it's 3 steps away on the pH scale. So that means you would have to go 10 times 10 times 10, or 10 cubed, which is 1,000. Okay, the first thing I'll do is I'll check this box so you could see the hydronium to hydroxide concentrations. So in water, because it has a pH of 7, and the concentrations of both of these ions are equal to each other, so it's 1 times 10 to the negative 7th for both of these ions, they're practically equal, which makes water neutral. Now, if I change this thing to something like battery acid, it's a lot more hydronium, so now the concentration is 1 times 10 to the negative 1 versus 1 times 10 to the negative 13 for hydroxide. And then you look inside the solution, it's a lot of the red stuff versus very few or barely any of the blue stuff. So that's why this thing is really acidic. It's got a pH of 1 because it's got a lot of the hydronium ions. On the other hand, if I change this to drain cleaner, you can see now it's a lot more blue than it is red. It's got a lot more hydroxide ions than it does hydronium. The pH scale makes understanding the relative strength of acids and bases a lot easier. It's a lot more relatable to say that something has a pH of 7 instead of saying that it has a hydronium concentration of 0.000001 or 1 times 10 to the negative 7 molarity. It's a lot easier just to say, oh yeah, something has a pH of 7, or something has a pH of 6, or something has a pH of 5, and so on and so forth. Finding the pH is easy. All you have to do is take the negative log of your hydronium concentration. So in the case of water, water has a hydronium concentration of 1 times 10 to the negative 7. If I put that in the equation, pH is equal to negative log times 1 times 10 to the negative 7, I would get a pH of 7. The hydronium concentration of battery acid is 0.1 molar. When you plug that into the equation, negative log times 0.1, we get a pH of 1. This means battery acid is 1 million times more acidic than water. Drain cleaner has a very small concentration of hydronium, 10 to the minus 13 molar. When you plug that into the equation, negative log times 10 to the minus 13, you get a pH of 13. This means it's not very acidic at all. It does, however, mean that it's very basic, and it's got a lot of hydroxide ions floating about. Before we wrap this up, you have to understand the difference between a strong acid and a weak acid. A strong acid will completely dissociate. That means every single one of its acid molecules will break into hydronium particles. On the other hand, a weak acid only does this sparingly. Most of it retains its original form. The 4 common strong acids are hydrochloric, hydrobromic, nitric, and sulfuric acid. 4 weak acids that only partially dissociate in water are hydrofluoric, hydrogen cyanide, acetic acid, which is found in vinegar, and carbonic acid, which gives soda and Coca-Cola its fizzy taste and sensation. Alright guys, thanks for tuning in and winning some acid-based chemistry with me. It's explosion time, and we're counting down at 3, 2, 1.